All right, welcome. Today we're jumping into something called k-means clustering. It sounds a little technical, I know, but it's this surprisingly straightforward and really powerful way that machines can find patterns in total chaos, all by themselves. So let's get right into it. So that brings us to the big, kind of mind-bending question, right? How can a machine look at this giant, messy pile of data and actually find meaningful groups inside of it without anyone telling it what to look for? I mean, it sounds a bit like magic, but it's actually a really fascinating process of digital discovery.
And the answer to that question? It all comes down to a type of machine learning called unsupervised learning. The name kind of gives it away, doesn't it? There's no supervisor, there's no teacher, and there is definitely no answer key. It's all about letting the machine just dive into the data and figure out the hidden structures for itself.
This here is a perfect way to see the two main paths machines can take to learn. Over on the left, you've got supervised learning. Think of it like studying with flashcards for a test. You have the question, you have the correct answer. The machine gets trained on all this labeled data. But then over on the right, you have unsupervised learning. And that's a whole different game. There are no labels. It's much more like being a detective who shows up to a crime scene and has to piece the whole story together just from the evidence lying around.
And that, right there, is the most important part. In unsupervised learning, the secrets are already locked inside the data itself. The algorithm's job isn't to predict some answer we already know, but to just explore the relationships between all these data points and let the natural patterns kind of emerge on their own.
So how does a machine actually pull this off? Well, one of the most popular ways is a technique called clustering. And this is where the magic of finding those hidden patterns really starts to happen.
You know, the official definition is pretty simple. Clustering is just the process of grouping similar things together. The whole point is to make sure that the items inside any one group, or cluster, are really similar to each other, but really different from the stuff in all the other groups.
To make this super clear, just imagine I hand you a giant, mixed-up bag of fruit. Even if you've never heard the words apple or orange before, you could still sort them, right? You'd put all the round, orange, bumpy ones in one pile and all the long, yellow, smooth ones in another. You're finding the groups based on what they look and feel like. That's clustering.
Now, there are a bunch of different ways to do clustering, but today we're going to focus on the star of the show, the k-means algorithm. This thing is an absolute workhorse in the world of data science, and for a really good reason. Okay, so here's the main idea in a nutshell. The k in k-means, that just stands for the number of clusters you want to find. It's a number you have to decide on before you start. The means part refers to the average, or the center point of each cluster, a point we call a centroid. The entire goal of this algorithm is to figure out the best possible spot to put each one of these centroids.
So, how does the algorithm actually find these groups? The process itself is surprisingly elegant, really. Let's walk through it step by step.
First, you pick k. Let's just say we want 3 clusters, so k equals 3. The algorithm then just randomly drops 3 center points, our centroids, somewhere in the data. Next, it goes through every single data point and assigns it to whichever centroid is closest. Now we have 3 initial, probably pretty messy groups. But here's the really clever part. The algorithm looks at each group and moves the centroid to the new middle point of all the data in its group. And then it just repeats. It reassigns all the points to their new closest centroid, and then it updates the centroids again. It does this over and over and over until the centroids pretty much stop moving. At that point, the algorithm has settled and you found your stable, well-defined clusters.
Now you might be wondering, how does it know what closest even means? Well, it usually uses something called Euclidean distance. It's just a fancy name for the straight line distance between 2 points. You know, the way a bird would fly. It's the simplest, most intuitive way to measure how similar 2 points are.
Okay, so we've covered the what and the how, but honestly, the most important question is, why should you care? Where is this abstract process actually being used? And believe me, the applications are absolutely everywhere.
Think about a company trying to understand its customers. K-means can automatically group them into segments, like budget shoppers or weekend spenders, so they can do better marketing. Or think about news websites that sort thousands of articles into topics like sports or politics automatically. It's even used in image compression, grouping similar colors together to make file sizes smaller. And a great example is movie recommendations. A service could cluster thousands of movies based on what users like. Figure out you're in the quirky sci-fi comedy cluster and suggest your next favorite film.
So, the big takeaway here is that k-means is this fundamental tool for finding meaning in raw, messy, unlabeled data. It's a way to turn total information chaos into something that's organized, understandable, and most importantly, something you can actually use.
And that kind of leaves us with one final, pretty exciting thought. We often use this to find groups we already think might be there, like different types of customers. But what's truly amazing is its power to uncover structures we never even thought to look for. So if a machine can find hidden groups we never knew existed, what other incredible patterns are just lying there waiting to be discovered in all the data that surrounds us every single day?